Hey everybody, welcome to another session of this math class where today we are going to study a really interesting topic, which forms one of the backbones of discrete mathematics, right? And which, as you see here, is set theory. So now to understand set theory, let's take few examples where we basically come across certain situations in life. Like say, for example, have you ever come across a situation where you wanted to classify your favorite movies into different kinds of genres, like say, this is drama, and this is mystery, and this is action, and then try to understand like which movies fall into both categories of drama and action, which fall into both mystery and action, and which fall into both mystery and drama, and then which fall into all three categories. That is this one. Or maybe your favorite sports players, like your cricket players, say this forms the list of ODI players, and then this circle shows you the T20 players, and then this circle shows you the test cricketers, right? So there are some players who play both test and ODI. Who are they? Who are those who play both T20 and test? And then who are those who play just ODI and T20? And then who are those who are the elite players who play all the three formats, right? If you have ever wanted to do this kind of an analysis, then you are exactly at the right place, and set theory helps you to do that, right? So what is set theory? So set theory is a branch of mathematics invented by George Cantor, right? To basically help you assist with these sorts of problems, right? So what is a set? In simple terms, a set is basically a well-defined collection of objects, right? Now, these objects might be anything, right? It can be like, say, fruits, like, say, apples, orange, banana, right? Or it can be, like, say, numbers, right? Maybe say only natural numbers or only fractions or only negative numbers, things like that, right? So when you talk about these sets, right, there's always a way of representing them. How do you represent these sets? There are two different forms. One is called as the Roster form, and the second one is called as the set builder form, right? So let's take examples of each of them, right? How do you define them basically? So for the roster form, you define the actual elements in the set. So let's say we have a set of natural numbers less than 10, right? So how do you represent them in the roster form? Let's say n is a set of natural numbers where you just say n equals 1, 2, 3, 4, 5, 6, 7, 8, and 9, because it is less than 10, right? Or you basically write it like this. Say n equals x, such that all x is a natural number less than 10, right? So say n belongs to all x such that x is a natural number less than 10. So this is basically the roster form And this is the set builder form, right? So another notation usually used is like n belongs to x, right? You can use that notation as well, right? And then how do you then visually or diagrammatically show sets? Is represented using a Venn diagram, right? So say you have the set of all animals that live on land, right? So like these are say terrestrial animals. And then you have the set of all animals that live in water. This is a set of aquatic animals, right? So the shaded region is the common region that represents those animals that live in water as well as on land. So the amphibians are represented by this region, right? The shaded region, because this region contains those animals that belong to this circle as well as this circle. So that's a common region, right? That's about Venn diagrams. Now, when it comes to set theory, we can also talk about certain operations on sets, right? Operations with sets. The first thing is union. Second thing is intersection. So let's take the same example, the one above, right? This one. Let's represent that again in a Venn diagram. So I said this is the circle of terrestrial animals and this is the circle of aquatic animals, right? So this is terrestrial and this is aquatic. So let's say the number of terrestrial animals under consideration are say 100 and the aquatic animals are say 150, right? And the amphibians are, let's say, 40 in number, all right? So the shaded region is 40. Let's say this is the set A. The terrestrial animals are represented by the set A and the aquatic animals by the set B, right? So what's going to be this union? This is given by A union B, which is basically the total number of animals under consideration, right? So how do you calculate that? It's given by the total number of only terrestrial plus the amphibians right? Amphibians plus the total number of only aquatic. Just focus on this word only, right? So how do you compute the total number of only terrestrial animals? Which is this region, basically. This region, right? Just this region. Like the partial moon, right? So how do you compute that? That's given by the total number of animals, terrestrial animals, minus the total number of amphibians, right? You have to subtract those animals which thrive on land as well as water from the total number of animals that thrive on land to get those animals which are only terrestrial. This is only terrestrial, 60, right? And then what is the number of only aquatic animals? The total number of aquatic animals minus the number of amphibians, right? That gives you this region. So it's given by 150 minus 40, which equals 110, right? So using this formula, only terrestrial is 60 plus the number of amphibians is 40 plus only aquatic, which is 110. This gives you the total number of animals, which is 60 plus 40 is 100 plus 110 is 210. So you have 210 total animals. So this is basically A union B, which basically represents everything that you have under contention. And what is A intersection B? What is this intersection? This is nothing else but the 40 amphibians. So A intersection B represents those elements which are common to both A and B, right? Which is in this case is amphibians. And there's a formula to remember in relation to this, that is the number of elements in A union B equals the number of elements in A plus the number of elements in B minus the number of elements in A intersection B, right? So if you try to substitute the values, this we found out to be 210. This should equal number of elements in A, which is like 100, plus number of elements in B, which is like 150, minus number of elements in the middle cell, which is 40, right? So 100 plus 150 minus 40 comes to 210, 250 minus 40. So this equals this. So this formula is verified, right? So that's about union and intersection, right? So let's cover another concept called as universal set. So what is a universal set? Let's say you have the same terrestrial animals, you have the aquatic animals, and then you have the amphibians here, right? Terrestrial, aquatic, and then amphibians. But then you also have birds, you also have insects, right? You also have other like microorganisms. So all of this forms a universal animal set, right? So this set that contains everything, U, is called as a universal set, right? So beyond this set of terrestrial and amphibian, you have everything else embedded in the universal set, right? And there's another interesting concept called as a null set or a void set, right? So what is this null set or void set? It's the same thing. So a set which contains nothing, right? It's empty. It's called as a null set or a void set. So one example of such a set is like A equals all x such that x is an even prime number greater than 2, right? So do you have any such even prime number that's greater than 2? No, right? 2 is the only even prime number. So this set A basically contains nothing. It's empty. This is a void set, right? Or a null set, right? So that's in short about set theory. There's a lot to this, but then this is a nice introduction for those people who were not familiar with this concept, or like those who were finding it hard to grasp this concept. So if you want me to cover anything more on the set theory, right, just comment in the video below. And if you want me to cover videos on any other topic, just let me know in the comment section below, right? So like the video and share and subscribe. Until then, thank you so much and bye bye, and see you in another video. Thank you. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.